Hi everyone, we are going to get started on a very important lesson on the basic power rules that we're going to use in this unit. Today we're going to learn the basics of what a base, exponent, and a power are, and the first few rules we're going to use in this unit. So to get started with this unit, we need to define what an exponent represents. An exponent represents repeated multiplication of a number. So, for example, if I was given that I had to multiply 17 times 17 times 17 times 17, I can actually just write that as 17 to the exponent 4. Or if I wanted to write 5 times 2 times 3 times 5 times 2 times 4 times 5 times 2 times 5, what I could actually do is rearrange this in a way that puts repeated multiplication together. So I know that this series of multiplications is the same as 2 times 2 times 2, so I have 3 2's here, times 5 times 5 times 5 times 5. I've got 1, 2, 3, 4 5's there, times 3 times 4. So I can actually rewrite that as 2 to the power of 3, 2 to the exponent 3, 5 to the exponent 4 times 3 times 4. Now, I make this mistake all the time. I've already done it in this video once. So let's go and properly define what a base, exponent, and a power are. So if I look at 2 times 2 times 2 times 2, I can see the base is 2. The base is the number that's being repeatedly multiplied by itself. The exponent in this case would be 4 because it's repeated 4 times. So the power is 2 to the exponent 4. So the mistake I often make is I say this is 2 to the power of 4, when actually it's 2 to the exponent 4, and the whole entire thing is what is referred to as the power. In the next one, we can see that the number that's being repeatedly multiplied is -7, okay? So in this case, the base is -7 and the exponent is 3. And we would write this as a power of -7 to the 3. And it's really important that we put brackets around the whole entire base to indicate that the 3 applies to the negative and the 7. So -7 to the exponent 3. It's not -7 in the front and then 7 to the power of 3, which is the next one. So if I see negative, then 5 times 5, the negative is actually on the outside. It's kind of like writing -1 times 5 times 5. Here, the repeated multiplication is 5. The base is 5. The exponent, so the number of times it's multiplied by itself, is 2. And I would write this as -5 to the power of 2 without brackets, because what this means is the 2 applies to the 5, but not the negative. So I don't need brackets there. All right, let's get to the first of 4 laws that we're going to learn today. So what we want to be able to do, is create shortcuts when we're working with powers. For example, if I look at A in this case and I wanted to simplify this, well, I know what this represents. 2 to the 1 is just 2. It's not actually repeated, it's just there once. And then 2 to the power of 2 means that I repeat the base of 2 twice. And I can see that this actually makes it 2 to the power of 3. Now, if you can imagine, I could write, for the next one, I could write 7 out 5 times, and again, twice, representing 7 to the exponent 5 and 7 to the exponent 2. but this can get pretty lengthy pretty quickly. And we can probably tell that there's a shortcut to this. And this is how we're going to write it down as a general rule. If I have a base of a, I can write this rule the following way. A to the m times a to the n, meaning that the bases are the same, can be written as a to the m plus n. If I look back to a, I can see that if I just add the two exponents together, that tells me how many overall times that base has been repeated. So now I can just use the shortcut for my next ones. 3 to the power of 3 to the exponent 3 times 3 to the exponent 2. All I have to do is write down the base of 3 and I add the exponents together. So these questions become very simple. X to the 7 plus 8 is x to the 15. Y to the 16 plus 21. Y to the 37. And this even works when one of the values is negative. So I'm adding negative 8. And if I'm adding negative 8, I'm actually subtracting 8. So I can write it as 10 minus 8. And this is 10 to the power of 2. Now, if I have any, come across any bases that are not similar to each other, what I can do is rearrange them in groups. So I can rearrange this because I'm allowed to do that with multiplication. Okay, and now I can use the rule on the bases that are the same. In this case, x and y. Okay, and I'm going to start skipping the middle step because I don't think we need to see it in some of the future questions. So here, again, I will rearrange. So 2 times 2 to the power of 7, a squared times a to the power of 9. And if I see no exponent there, what's implied is a 1. Okay, so I'm going to skip the step where I write the addition, but I know my final answer is going to be 2 to the power of 8 because I'm adding 1 plus 7 and a to the power of 11. All right, 2 more here before we move on to our next rule. So we're going to rearrange this by putting all the similar bases beside each other. And then we're going to use our exponent rule, number 1, to add the exponents together because the bases are the same. All right. And we don't actually have to write those dots in if we don't want to. You can write it like this. These are the same thing. Okay, so what happens when two numbers or two bases are not the same? Well, we're going to still put them together. So negative 4 times 7, and we're going to put the y's together. And because they're not the same base, I can't use an exponent rule, but what I can do is just evaluate negative 4 times 7. So I'm going to write this as negative 28 y to the power of 9, y to the power of 4. Okay, now let's move on to the next law. The next law has to do with the division of powers. So if I were to write this using repeated multiplication, I can first write this, instead of using the division sign, I can write it as having a numerator and denominator. And then I can actually write this as repeated multiplication. All right. And I can see that in order to simplify this, I can just make cancellations. And I can see that the 3 5s in the bottom cancel with 3 of the 5s in the numerator, leaving 2 of them behind. But what I can probably also see is that a short way to get this is to look at the exponents of the bases and recognize that when I'm dividing these two powers, what ends up happening is my denominator cancels out the ones in the numerator, so I can actually just subtract the exponents. We'll do it one more time the long way, but I could probably see even before doing this that I know all I have to do is subtract the exponents here. So to write my exponent law 2, if the base is a, and I have a question, a to the m divided by a to the n, I know that my final answer is going to be a to the power of m subtract n. All right, so using this shortcut, let's do the following questions. So I can just write this as 3 to the exponent 6 minus 3. And I mean, sure, in the end, we could be evaluating these, but I would like us to write our answers as powers for this lesson, so we can get used to that. So this is going to be x 15 minus 5, x to the 10. This we wouldn't be able to evaluate because it's a variable. Okay, now we're getting to questions that have 2 steps. And if you remember, in terms of order of operations, we always, because division and multiplication have the same priority, what we would do here is make sure we're doing the operations from left to right. So we would be doing the division first. And then we would be adding these 2 exponents together. Another way to do this, if we wanted to do this all at once, we could just write it as one step, 18 subtract 12 plus 6. And we'll get the same answer. So that's y to the power of, sorry, this should be a 4. That'll be y to the power of 10. Here we have a negative exponent, but don't forget we're still subtracting, so in the end, that becomes addition. Okay, and here we go, we have another 2-step question. So what I'm going to do is simplify the numerator first, and then use subtraction of the exponents for that final answer. And we wouldn't evaluate this because this number is actually too big. All right, so for h, what I'd like us to do is consider that there are 2 different bases we're seeing here. We're seeing 2 and x, and what we would do is sort of consider them as separate fractions. So what I can do is write this as 2 to the exponent 8 minus 6 times x to the exponent 7 minus 4. So this becomes 2 squared times x to the power of 3. All right, and then finally for this one, we can combine a squared times a to the power of 5, which is a to the power of negative 3 over a to the 7, and we are going to subtract these exponents. Okay, and this is the first time we're seeing a final answer with a negative exponent. We're going to move, when we move on, we're going to talk more about negative exponents in a future lesson. But for today, this final answer is okay. All right, now let's try to maybe write them down in one step, which we can do. So this will be 3 to the power of 12. And again, I'm going to break these up into similar bases. So it'll be 6 to the power of 6, y to the power of 5, and z to the power of negative 4. All right. When the numbers get big, that's okay. We still treat them the same way. Except maybe we need a calculator. X to the power of 6. All right, exponent law number 3. Now for this one, what we want to recognize is that, so I'll do a, quote, the long way, But basically, using BEDMAS, if we were going to do repeated multiplication, we can see that this is the same as writing 2 times 2 times 2 squared, which would actually be 2 times 2 times 2 times 2 times 2 times 2. In the end, we have 6 2's. And if I look back at the original question, I could see that actually what I would be doing is multiplying these two exponents together to get that number, because it represents the total number of repeated multiplications. So again, if my base is a, okay, if I have a to the power of m raised to the exponent n, I can write that as a to the power of m times n. So what I would do is multiply the exponents together. So in this case, it's really simply 3 to the power of 10. Now, what do I do when I have fractions? Well, that's fine. All this means is that the base in this case is 1 over 4. So I just have to make sure that my final answer has brackets around it. Okay, because my whole entire base of 1 over 4 will be raised to the power of 6. All right, we have a two-part question next, but we can just do it step by step. So I'm going to simplify the power of a power there, and then I will add together the exponents. And 4 times 7 is 28. All right, so BEDMAS says exponents come first, so we need to simplify the exponents first, and then we can do the division, which is subtraction. Same thing here, I have to apply the exponents first, and then I can do the division. All right, so exponent law number 4 is actually a warning, meaning that there is no rule for addition and subtraction of powers. So I'll tell you what the common mistake is here. The common mistake here is to look at this question and confuse it with the addition rule. So a common mistake is that a to the m plus a to the n equals a to the m plus n, but actually that's not true. Okay, we know that a to the m times a to the n equals a to the m plus n. So what do we do when we have a rule like this? Well, we do what is called evaluating. And evaluating means you're actually going to tell me what the power is in a simplified integer, or fraction if it's a negative exponent, but that comes later. So for today, these will all be integer values. So 2 to the power of 2 is 4, and 2 to the power of 3 is 8. So overall, my final answer is 12. If I were to do this incorrectly, I would get 2 to the power of 5, which is actually 32. And this one is just incorrect. That's incorrect. So I cannot use a rule there. All right, so I'm going to do the next one, negative 3 to the power of 4. So with this one, I can put it in my calculator, but if you want to remember, it's repeated multiplication of negative 3 4 times. My final answer is going to be positive because the negatives cancel out. I'm going to get 81 subtract 27, which is 54. Okay? So exponent law number 4 is that there is no law. Evaluate the powers and then add or subtract. So we're getting to the phase in this unit where we might try to trick you a little bit, and it's not really on purpose. It's just to test that you know to keep these rules separate. All right, so here we go. What we're going to do is evaluate and use our calculators to answer these questions. 456. Now here, this is not a trick. I can actually use a rule there because this is multiplication of powers. So 5 to the power of 6 subtract 5 to the power of 3, but I cannot use a rule there. I have to actually go to my calculator and figure this out. All right, let's look at the next one. We might have to break this down a little bit. So I can see multiplication, 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 but of these, only this one here has the same base. So I'm allowed to use the rule here, but for the other ones, I can't use a rule. I have to evaluate the powers. So this is going to be 2 times 9 plus 2 to the power of 7 subtract 5 times 27. So there's no way to combine two bases if they're not the same. All right, again, multiplication, division, and these bases are in fact the same, so I can combine them. And that last one I'm going to write as 9. 5 to the power of 4 is 625. Subtract 27 minus 3 plus 9. My final answer is 610. It's a good number. All right, so what I would like you to do now, please pause the video. I want you to give these questions a try and then come back to the video and see if you got the right answers, okay? Good luck. If you have any questions, please reach out to your teacher. Come see us in Extra Help. We are here to help you. Good luck.